Hi everyone. So today we will talk about data types in Python. Okay. So what are data types? Data types allow Python to classify the data in your Python program. Okay. Data types allow Python to classify the data in your Python program. So consider a Python program a equal to 10, okay, b equal to 20.5. Now print a plus b. So Python interpreter will get to know about the data types of a and b at runtime, and it will check if addition operation is allowed between those data types or not. If addition operation is allowed between those data types, then it will print a plus b. If addition operation is not allowed between those a and b, then it will throw runtime error. Okay. Different operations can be performed on different types of data. That means the operations that are valid for one data type might not be valid for the other data type. So let us say you performed an operation on data with a particular data type, but that operation is not valid on the data type. Then what will Python will do? Python will throw runtime error. Okay, that means you try to perform a invalid operation on a data for a particular data type, and that since that operation is invalid, Python will throw runtime error. Okay. Now consider this Python program. Okay, a equal to hello, b equal to how are you, print a minus b. So now here what I am trying to do, I am trying to perform subtraction between two string variables. Okay, but subtraction operation is not allowed, okay, between variables of string data type. So what Python will do? Python will throw runtime error. Python will throw runtime error. It will check the data types of a and b at runtime, and it will see that subtraction cannot be performed between such data types, and it will throw runtime error. What are the basic data types in Python? Okay, we will see the basic data types in Python now. Okay, integers are one kind of basic data types in Python. Float, complex numbers. Of course we will be discussing about complex numbers later, but not now. Strings, everything is an object in Python. The integers, strings, floats, all are objects only. Okay, consider a program a equal to 10, b equal to 20, c equal to some string. Okay, a, b, c all are objects only, whether they can be integers, strings, floats, whatever. Okay, so everything is an object in Python, and this is how an object is defined in C Python implementation of Python specs. Okay, so this is a C Python implementation object. You can see something called by object add extra, and you can see something related to object reference count, and you can see object type. So we will talk about this definition later. Okay, but this is how an object is defined in C Python implementation of Python. Okay, so this is the object. Object contains object type. That means whether it is an integer object, float object, string object. Okay, in that way, and it contains the object value, the actual object value. Let us consider a equal to 20. Then object type will be integer and object value will be 20. And reference count. Reference count in the sense, consider this assignment a equal to 20. That means this object 20 is being pointed by a reference variable a. So in that case, the reference count will be 1. Okay. Now consider another example. A equal to 20, b equal to a. Okay. In this case, the reference count of object 20 will be 2, because 20 is earlier pointed by a and we are saying b equal to a. That means b is also pointing to the object 20. That means the object 20 is being pointed by 2 reference variables. That is the reason the reference count is 20. So the object will have object type, object value and reference count. Now we will talk about each and every data type in detail. Okay. First we will talk about integer data type. So integer occupies more memory in Python when compared to that of in other languages. Yes, when compared to other languages, integers in Python occupy more memory because integers are objects. Okay, unlike other programming languages, in Python integers are objects and objects in Python have memory overheads. Okay, objects in Python have memory overheads. What are those overheads? Those overheads are nothing but the reference count that we are talking earlier, the data type, okay, and the pointer to the object. Yes, in Python we don't have pointers, but this particular object is defined in CPython implementation. In CPython implementation, you will be having pointers. So that is the reason we are talking here about the pointers. Okay. So objects in Python have memory overheads. That is one reason why Python integers will occupy more memory. So integer objects in Python have memory overhead of 24 bytes. This is what I mean by memory overheads. Like an object contains object type, object value and reference count. So all this will take 24 bytes of memory. This is what I mean by memory overhead. Now take this example. Let us take an signed integer within the range minus 2 power 31 to 2 power 31 minus 1. Okay. If you take any signed integer within this range, okay, that particular signed integer can be represented using 4 bytes of memory. Okay. If you exceed this range, then that particular signed integer can be represented using 8 bytes of memory. But in this particular range, 4 bytes are enough to represent an integer. That means earlier we have a overhead of 24 bytes and now we need another 4 bytes to represent an integer within this range. That means 24 plus 4, that is 28 bytes are required for an integer variable. Okay. That means the number of bits required to store an integer object in memory is 24 bytes of memory overhead, 4 bytes for the actual value provided that falls in this range. Okay, that is 28 bytes of memory are needed for an integer variable. What is integer? This integer is an object of class int. Suppose a is equal to 20 you have taken. The 20 is an object of class int. A equal to 260. Okay. 260 is an object of class int. So this is your py object. Now we will see what exactly happens when this particular line of code gets interpreted by Python. A equal to 260. Okay, what will happen? Memory gets allocated for this object, and then value of 260 gets assigned to that object. Then a reference variable A starts pointing to that object. Okay, so what is this py object? Py object is an C Python implementation. So type will be int. This is one of the memory overhead that we have in the object. Value will be 260. So this is talking about the data type. Data type is equal to int, value is equal to 260, reference count 1, because this object is pointed by one reference variable. So this is your py object. This is all the memory overhead that it is having. Okay. Integers can be positive. Okay. When I say positive, they can be 0 also. Okay. Integers can be negative. Integers are immutable. We will see what I mean by immutability. Okay. And integers don't contain any fractional part. Integers can be positive, including 0. They can be negative. They are immutable and they don't contain any fractional part. Integers in Python are immutable. What I mean by that? Consider this example, a equal to 260. Okay. What will happen? This object 260 will be pointed by reference variable a when I say a equal to 260. Okay. Now I will say a equal to a plus 1. That means I incremented the value of a by 1. Then what happened? Till this point, this reference variable pointed to value 260, but when I said a equal to a plus 1, reference variable a started pointing to 261 and 260 object is left alone and it will be removed by the garbage collector. Why this is happening? Because integer objects in Python are immutable. Whenever you try to increment or change the value, a new copy gets created. Okay, it is not like mutating the same object. It is not like that. Instead, a new copy gets created. That is the reason now your reference variable a will be pointing to the new object. Now we will see integer catching. Okay. Python will be catching integers in the range -5 to 256. Okay. Let us say I say something like a equal to 255. A equal to 255. 255 is not in that range. Okay, then what will happen? Python will not create any new object copy. Instead, it will give the object that is already catched, because integers in this particular range are already catched, pre-catched, you can say. So it will just return that catched object instead of creating a new copy. A equal to 2, another example. Now 2 is in the range -5 to 256. So what will happen? It will not create any new copy. Instead, it will return the catched version of that particular integer object. Yes, no new object is created in the memory because 2 is in the range -5 and 256. So what will happen when I say a equal to 2? A will point to the already catched object in the memory. So till now we talked about integer data type. Now we will talk about float data type. So unlike integers, float will include a fraction. It contains a fractional part. Even floats are immutable, just like integers. Sum of float and int is again a float. Okay, when you add an integer variable with a float variable, you will be again getting a float variable as the result. Consider this example: a equal to 12.5. This is an example for float. Okay, you can see the fractional part. Float variables consume 24 bytes of memory. So of those 24 bytes, 16 bytes are for the pointer and the reference count, which is part of the memory overhead, and another 8 bytes for the actual object. So 16 bytes are used for the memory overhead and 8 bytes for the actual value. So that is 16 plus 8, 24 bytes are needed for a float variable. You can get the size of an object using the below statement. So you need to first import sys module, okay, and then you can say something like sys dot get size of the variable. It will give you the value as 24 bytes. So float object will consume 24 bytes of memory. Out of those 24 bytes, 16 bytes are used for memory overhead and the remaining 8 bytes for the actual value. Okay. Now we will talk about string data type. Okay. So what is a string? A string is a sequence of characters. Okay, string is a sequence of characters, and a string object is again immutable, just like integer and float. A string object is also immutable. Okay, consider this example: a equal to devseat. This is an example of a string, and it is a sequence of these characters: DEVSEAT. Okay, this is one example of a string and it is enclosed in double quotes. This is one more example of a string. It is again a sequence of characters, but it is enclosed in single quotes. Even this is a string. You can have your string this way as well. You have double quotes and a single quote, and again a single quote and then double quote. This is also a valid string. If the string starts with a single quote, then we need to make sure that the string ends with the single quote only. If your string starts with a double quote, we need to make sure that the string ends with double quote only. Okay. And this is not a valid example because your string is starting with a double quote, okay, and then a single quote, but it is followed by a double quote instead of a single quote. This is a invalid string. Now we will talk about backslash in Python. Okay, so what is backslash? It is also called escape character. Backslash is also called escape character. What is its significance? What is the significance of backslash character? Consider a string. Okay, consider a string with special character, and your requirement is such that you don't want that character to be treated as special character by the Python interpreter. You don't want that character to be treated as special character by the Python interpreter. In such cases, you can use backslash. Okay, in such cases you can use backslash. So when you add backslash, this is a backslash. Okay, when you add backslash to a special character, that particular character will be escaped from being treated as a special character by the Python. So if you add backslash to a special character, that particular character will be escaped from being treated as a special character. It will be treated as normal character only. Consider this example. Print I am learning Python. Okay, actually this looks like a valid English statement which is present between two quotes I apostrophe M, but it will be actually treated as a one more quote in Python. That means in this particular string you have two quotes here, but this string is being ended by only one quote. So what Python will do? Python will throw error. This will throw, if you do this print statement, even though this is a valid English statement, but still Python will throw syntax error because there is an uneven number of single quotes present in the string. Okay, there will be a syntax error. So what we can do here, we can actually use backslash in the above statement to solve the issue. Okay, you can add backslash so that this quote can be escaped from being treated as a special character. So you can do something like this, print. So we can add a backslash before the apostrophe so that this particular quote will not be treated as special character and it will be escaped from being treated as a special character, and it will print value without throwing any error because we have used a backslash. Okay, now if you use backslash t, okay, then 4 spaces will be added between words. What I mean to say is like, I will say something like I backslash t like backslash t Python. Then what it will do? It will add 4 spaces between I and like, and 4 more spaces between like and Python. Okay, that is what will happen when you use backslash t. Now we will talk about backslash n. Just like how we have backslash t, which is used for adding 4 spaces between the words, now we have backslash n. So what it will do? It will allow you to print in a new line. I mean to say, here we have I space backslash n like space backslash n Python. So when I try to print this, what will happen? First I will get printed and like will be printed in a new line because before like we have backslash n, and again after like Python will be printed in a new line because before Python we have again backslash n. So the output will be I like Python because backslash n makes you print in a new line. Okay, that is what all about backslash n. So backslash t will make you print with 4 spaces between the words, and backslash n will allow you to print in a new line. An empty string takes 49 bytes of memory. Okay, how much an integer object will take? It will take 28 bytes of memory. A float object will take 24 bytes of memory. In the same way, an empty string takes 49 bytes of memory. Okay, now what is a string? A string is a sequence of Unicode characters. That is what we have learnt. A string is a sequence of Unicode characters. So let us say we have a string a equal to dev seat. So how much an empty string will actually consume? An empty string will consume 49 bytes of memory. Okay, and now we have a string a equal to dev seat. Now each character will consume 1 byte of memory. Here we have 7 characters, that means 7 bytes of memory will be consumed. So what is the total amount? Total amount will be 49 characters, I mean 49 bytes for the empty string and 7 more bytes for the 7 characters. So that is 49 plus 7 equal to 56 bytes are being consumed for the string a equal to dev seat. So the string a equal to dev seat, this can be visualized in the below way, okay, in the main memory. So this is how it gets stored in the main memory. So a string is a sequence of characters, sequence of Unicode characters with indexes starting from 0 and ending from length of the string minus 1. Here the length of the string is 7 because it contains 7 characters. So the index will end at length of the string minus 1, which is 6. So indexing starting from 0 and ends at length of the string minus 1, which is 6. So the character D will be at index 0, E sits at index 1, B sits at index 2, okay. In the same way T sits at index 6. So dev seat is a string which is nothing but a sequence of characters, okay, with index of the sequence starting from 0 and ending at length minus 1, that is 6. It is a sequence of Unicode characters, and you can access those characters using the indexes. That means since this character sits at index 0, you can access it using the index. So a equal to dev seat is your string, right? If you try to access that particular character, you can do that by saying a of 0. A of 0 will give the character D. That means element D can be accessed using a of 0. Okay, element D can be accessed using a of 0. Element E can be accessed using a of 1. In the same way, element B can be accessed using a of 2. Similarly, element T can be accessed using a of 6. So you can access the elements using the index. Now we have negative indexing as well. Just like how we have positive indexing starting from 0 to length minus 1, we do have negative indexing as well. But negative indexing will start from the end and it starts from minus 1. Positive indexing starts from 0, but your negative indexing starts from minus 1. Okay, so similarly a of minus 7 gives the character D. Okay, a of 0 gives the character D. In the same way, a of minus 7 gives the character D, because your indexing, negative indexing starts from minus 1. Okay, so D sits at the index minus 7, and a of minus 6 again gives the character E. So a of 1 gives the character E. In the same way, a of minus 6 gives the character E. Similarly, a of minus 1 gives the character T. Okay, and one more thing, you cannot concatenate an integer and a string. Okay, you cannot concatenate an integer and a string. Then what will happen? Python will throw a runtime error if you try to concatenate an integer and a string. You will be able to concatenate two strings. Yes, you can concatenate two strings, but you cannot concatenate an integer and a string. Of course, in the same way, you cannot concatenate a float object and a string. Now we will see f-string statement. This f-string statement is used to concatenate strings. Okay, we use f-string statement to concatenate strings. Consider this small program. What it says? It says language equal to Python. Okay, now I am trying to concatenate that particular string variable with I like to form I like Python. So my intention here is to print I like Python, and that can be accomplished using f-string. Okay, so using f-string I am trying to concatenate Python with I like. So how I am using f-string here? So inside this print statement I can see f. Yes, this is the f string, and whatever I am trying to concatenate, I just added that as part of curly braces, that variable. So what is this variable? This is my variable defined. Okay, language equal to Python. So what this print? It will print I like Python. Using plus operator also you can concatenate two strings, but it is not recommended to use plus operator to concatenate strings. Instead, go with f string only, because what happens when you use plus operator to concatenate two strings? A new copy gets created because string is immutable. When you are trying to concatenate two strings using plus operator, a new copy gets created. Okay, that is not the case when you use f string. So it is always better to use f string instead of plus operator. There is lot more left to discuss on data types, and we will continue that discussion in the tomorrow's session. Okay.